Good morning, everyone. Welcome to the tutorial on target class learning for anomaly outlier detection, a robust strategy. In 26th International Conference on Pattern Recognition, ICPR 2022. On behalf of all my proposers, I would like to welcome you all. I am Dr. Sonali Agrawal, working as an associate professor at IIIT Allahabad, India. I would like to introduce my colleagues, Dr. Sanjay Kumar Sonbhadra, Dr. Narinder Singh Pun, and Professor P. Nagabhushan. We all are presenting this tutorial to give you an exposure towards target class learning for anomaly or outlier detection. We have divided this tutorial into 5 parts. Part 1 is focused on the introductory sections. Here we are covering learning strategies and state-of-the-art representation of anomaly detection techniques. In the part 2 of the tutorial, we will be covering one-class classification models, especially in the light of target class learning. Part 3 of the tutorial is focused towards target class guided data reduction for target class mining. So here we are including target class guided training sample reduction and target class guided feature reduction. In the fourth of the tutorial, we will be covering various deep learning methods for anomaly detection. Final part of the tutorial is including conclusion and future scope. So let us start the first section of the tutorial. It is about learning strategies. So as we all know, like we are flooded with the data, but we are starving for the knowledge. So due to this present situation, learning strategies are become very crucial for our various day-to-day applications. So we all know that supervised learning is one of the techniques which is widely used for many of our real-time applications. In supervised learning, the data is labeled, and with the help of this data which is labeled, we predict outcomes or future instances. And here, the main objective is to perform a typical classification task or a regression task. So these supervised learning applications are widely used in many use cases, for example, like fraud detection, spam detection, and image classification, especially in the type of classification. Whenever we think about the regression models, so regression models are useful for various kinds of predictions, for example, like sales and marketing predictions or predicting certain prices for some decision making, policy decision making for any marketing campaign. Other than supervised learning, we are having another learning environment, which is unsupervised. So in unsupervised learning, we all know that data is not at all labeled, and we are working in an unsupervised fashion. So basically, we are going to experience some new set of data, for example, like clusters, or we may also able to identify some kind of patterns and structures. So clustering is the main example of unsupervised learning, and we have various applications related to the unsupervised learning, for example, like anomaly detection, recommendation system, and many more studies where we are not having the initial clue, but we will be definitely looking for some hidden patterns such as genetics. Similarly, unsupervised learning is also useful whenever we try to explore various existing associations among the data parameters. Another category of learning environment is the reinforcement learning. Here in reinforcement learning, we assume that whatever data we are having, it is not at all predefined. But here we actually work with the system or we interact with the system, and during our interaction only we try to learn from the system. So here we are not only the exploiting the existing systems but also exploring the existing system so that we can learn something which is useful and we can discard whatever we find that it is not at all useful. So basically here we are learning a series of actions to maximize the reward. There are various examples where this reinforcement learning is very popular nowadays. For example, developing autonomous vehicles, developing various kinds of games, and in the present context, even the healthcare domain is also utilizing reinforcement learning to explore and exploit the recent developments of the healthcare environment. There are other possibilities which help us to learn through the data. And data nowadays data becomes very challenging because of its huge size as well as its a huge velocity. So basically one of the approach is like we are training from the scratch. So here we are using various layers, for example like input layer and base models, and here in the base model we are training the entire model, and finally we are giving the learning outcomes to the output through the output layer. Similarly, there can be a possibility like just to reduce the efforts, if it is possible, we can what we can do, like we may not be able to learn in a scratch right from the sketch, but we can have the learning where we can learn while keeping the low level layers frozen, and we need to train only the higher level layers. Or sometimes we can also use the completely pre-trained models for the training purpose, and we may accordingly extract the knowledge through transfer learning. So basically we are having these three examples here like A, B and C, you can see. So here in this first case we are training the entire model, which we can say that we are training from the scratch. Okay, so this is basically your base model where we are having a rigorous training. In the second option, we are not training the entire model, but we are training only the high level layers with the help of the some of the initial knowledge which is available. And here in this last one, we are not at all using any effort for the training phase, but we have used the pre-trained models and trying to get the knowledge through the transfer learning approach. So transfer learning is basically, it is one of the example of the deep learning model where we avoid learning from the whole scratch, but we try to utilize the pre-trained models. So pre-trained models may be of the same domain or maybe of the different domain. And we try to adopt the pre-trained models for the present domain and for the given task. So there can be several possibilities available. Like sometimes we are using the pre-trained models for of the same domain, but maybe for the different task. And sometimes we can use the pre-trained models of the different domains, but maybe for the same task. So basically, this transfer learning is having an approach which we call like transfer of knowledge approach from source model to the target model. So it is having very obvious advantages, like we are saving our time, and it may be facilitating the faster training because in transfer learning approaches, we are not learning from the scratch. And here it can also work with the limited, annotated or labeled data. And it is also verified that these transfer learning models are having less computation power requirements as compared to the typical deep learning models. We are having some recent developments in these learning strategies. For example, like zero-shot learning, one-shot learning, and few-shot learning. So this is the demand of these era where most of the time applications are continuously changing. So sometimes there is a possibility that we are having certain trained model, but the testing sample which we are experiencing may not be as similar to the data which is used for the training purpose. So that can be the case of the zero shot learning. And sometimes what we have, like apart from all the existing data which we used for the training purpose, maybe only one sample is matching at the time of testing, or maybe a few samples are matching at the time of testing. So basically, here this is something which is very challenging, but it is very much uh, uh, popular these days. So here what we do, we try to utilize these zero shot, one shot, and few shot learning approaches uh, to uh, to solve various applications in the area of face recognition, machine translation, and caption generation. So we can say that there are various problems which are still unsolved while dealing with all these learning paradigm. So basically, for example, let us take the transfer learning models. So we are using pre-trained models, but sometimes these pre-trained models may not fit for the domain on which you are working. So there may be challenging requirements we are facing day by day. For example, like biomedical imaging. After this COVID-19, the scenario is completely changed. And again, there are various pre-trained models available, but they may not be sufficient enough to cater the requirements of biomedical imaging. So other than this, even it is very difficult to develop the pre-trained models because uh, getting the real labels is a very time taking task. And we can say that sometimes it may not be sufficient, uh, uh, even if we are having very broad categories for these kind of uh, pre-trained models in terms of its labeling. And we can also say that this labeling is something which needs a lot of human intervention. And if we are using the pre-trained models, so getting any new level later and trying to incorporate it for the preparation of the pre-trained model may become a difficult task. So basically, although we say that this ImageNet data set is a huge data set, but again, you may find out that there are various cross-domain specific requirements which may not be supported by this ImageNet pre-trained models. The another challenging issues are, like, we are sometimes exposed to the rare concepts. So rare concepts means it can be any abnormal activity, it can be any rare activity, or it can be anything which we have not yet experienced. So for such type of situations, the data availability is less, and the data labeled samples are also not available. So if we are dealing with such type of cases, then it would be very difficult for any models to adopt the features from such rare events uh, through the help of the supervised learning. The another difficulty is dealing with the complex data. So first of all, like the data is generating in a very huge size. So annotating all these data can be very difficult. And sometimes the data which is having some critical domains, for example, like biomedical imaging, it becomes very difficult to manually label them. So sometimes it is time consuming, sometimes it is very much tricky, and sometimes it is having uh, costly also. So these are the problems which we are dealing in the present learning environment. And another problem is like, although we are using supervised learning platforms or supervised learning models, but whenever we try to predict, uh, uh, there are certain discrepancies in the outcomes. So we can say that, suppose this is one example which is given. Here a prediction was made by five publicly available image recognition systems for the images of household items across the world. So you can say that if we are taking data from such a large community, so there is a problem that these large community may have different presentation of that particular uh, scenario. So you can say that, like, although it is a soap, but it was misclassified by many of the classifiers because of the variety of the instances available according to the wide range of geographical locations and its representation. So that is again a problematic issue. Like, uh, whenever we use the supervised learning model, the class level which we identify may not be covering all the possible instances, and there can be certain variations of the available instances, and as per the fixed class labeling approach, it may not fit. So how to solve this hardcore class labeling restriction or problem? So one can suggest that we may obtain the labels maybe dynamically, or maybe automatically, or maybe with the help of some less efforts, or you can say that semi-automatic processes. So for that we can use the metadata, and we can use the GPS locations, captions, hashtags, and some other representative uh, parameters. So this can be a weakly supervised learning approach. So here weakly supervised learning approach means we are deciding the levels with the help of some various kinds of factors. Or sometimes this approach may not also help for the variety of the domains. So one very revolutionary approach is here, that is self-supervised learning, where we are learning from the data itself. So we here in this tutorial, we are focusing on some of the specific conditions of these learning paradigm. So first is like, if we are dealing with the availability of only single class samples. So that is very likely, like for example, like most of the normal cases or healthy cases, data can be easily available. But suppose we are doing we are trying to extract the data from some abnormal situations. For example, like we are extracting the data of the patients from rare suffering from rare diseases, or maybe we are trying to extract the data for the case of certain very critical accidents. So these kinds of data are actually not available. So it is a need to work with the data sets which are available and that may belong to the single class only. So there can be various possibilities, like during training, if only a single class data are available, or other class data may be ill-defined, or some other class data are completely absent. So this can be one problematic situation. So if we are trying to accommodate these kinds of problem uh, in in the existing learning environment. So one solution could be moving towards target class samples or target class mining, or we can say that we should explore the possibility of one class classification models. So basically in this tutorial, we are trying to solve these problems mm, of learning environment where we have we are lacking with the availability of data from all the classes, and we are bound to work with the limited class available data. So there are certain approaches which we have explained here, such as like target class guided training sample reduction and target class guided feature reduction. Before moving to that, I will be taking one very common use case where we feel this kind of situation, that is the availability of data from one class only is anomaly detection. So here in this part of the tutorial, I will be covering various anomaly detection methods, techniques, and its applications. So we all understand that anomaly is a pattern in the data that does not conform to the expected behavior. So we call sometimes anomaly as outlier, exception, peculiarities, or surprising. And anomaly can be very common experience in our real life. For example, like uh, card for fraud detection or cyber intrusions. So because these are not very regular activities, but it can happen. So basically this may be surprising. So these activities can be kept under observation while studying the anomaly detection. So here we can see one simple example of anomaly uh, detection. So you can say that suppose we are trying to plot the data points. So it is a very common understanding that there may be means data they can be appear uh, in a group or in a cluster. So that can be considered as a common behavior. But if certain data samples, if they are appearing at some distant from these normal appearance, maybe the normal clusters, so that can be identified as anomaly. So here points O1 and O2 can be the anomaly. Point O3 can be a new cluster, but since it is far away from the normal regions, like that is N1 and N2, so this can also be seen as an anomaly for certain specific circumstances. So this is the typical representation of anomaly detection. So anomaly detection is having a major role in most of the applications which we deal in our day-to-day life. So, for example, like if we are inspecting any credit card users pattern, so you can imagine that uh, if there are sudden increase in the credit card purchase, uh, so that sudden increase may sometimes normal. For example, if it is a festival time such as Christmas, so that can be a normal. But if the sudden increase of the purchase pattern we are observing during the non-festive days, so it may become a kind of anomaly. So that maybe it needs more attention from the user side, or and some preventive measures are required. Uh, Sometime what we can also see, like this anomaly detection can also be useful while observing the safe and unsafe behavior of the user. So for example, like if we are aware about the user's locality at a particular machine or in a particular geographical environment, so if we are facing any change in these patterns in terms of accessing the network, So that may not be a normal case and it can be detected as an anomaly. So we have identified certain similar keywords which are related to the anomaly detection. We call it rare class mining, chance discovery, novelty detection, exception mining, noise removal, and black swan. So black swan means usually we feel that there are swans which are most of the time very normally white in color. But if within that, if we are having something very unusual, for example, a black swan, so that can be really identified as an anomaly. So we will be considering some of these examples in our rest of the part of the tutorials. So before going to the various state-of-the-art techniques of anomaly detection, I will be discussing here a typical anomaly detection model. So in this typical anomaly detection model, we are gathering the data to generate some kind of system profile. Okay. So system profile generation may be, it is assumed that we are taking all the normal use cases for this. But if we are over a period of time, if we are observing any kind of deviation from the normal system profile, so that deviations are important to identify. So that can be a kind of anomaly detection task. So this anomaly detection task we can perform by measuring the deviation with respect to some benchmark or some kind of the reference, and maybe we may able to generate certain responses. So that is basically the anomaly detection model. So we have various components like data collection components, so that it can be helpful to generate the system profile. And then anomaly detection. So anomaly detection is like we need to compare the current activity and with the help of some normal activity or normal profile. And these comparison is nothing but we have to observe the deviation, and we can flag this deviation as a normal or abnormal. And finally, whatever response we will be giving, that response may be the outcome of that anomaly detection model. So if we see what are the advantages of these kind of anomaly detection systems, so this is very important if we are trying to ensure the safe environment in many of the domains. For example, it can helpful to detect the attacks or previously unknown attacks over the network domain, and it can also able to detect misuse of any kind of resources. And with the help of this, we can also able to collect some kind of novel information which is occurring first time in most of the cases. For example, like any rare disease occurrence, any rare symptoms which we are identifying while observing the patient's vital parameters. So basically it is very common that these kind of situations are available. And if we are detecting it on time under certain preparatory action, so we may able to handle that situation, and we may also able to minimize the impact of such kind of surprising situation or maybe unknown activity. So it is also useful for the various kinds of behavioral modeling. So with the help of this, we can able to model the behavior in terms of normal and abnormal. And we can also able to identify certain parameters which are useful to maintain the normal behavior of the system. Okay. And that can be also think in another way, for example, like overhead. So every time if we are continuously trying to detect some anomaly, so there may be possibilities that we are not experiencing any anomaly, because most of the time the working pattern is coming normal. So here it can be a computational expensive task. Okay. Then sometimes what will happen, like even we are trying to detect an anomaly, but because of the limited availability of the data, that anomaly cannot be distinguished, and maybe it is coming as one of the matching with one of the existing classes. So basically, for example, like false alarm uh, rates can be possible here. So that can be a costly affair. And the another thing is, like if we are not calculating the anomaly with the help of certain appropriate features, then also it may lead to some wrong conclusion, and it may decrease the effectiveness of the anomaly detection system. So these kind of things which are an overhead while using the anomaly detection systems with the various kinds of learning environment for some better decision making. So these are few of the applications of anomaly detection systems. For example, like network intrusion detection, insurance, credit card, fraud detection, healthcare informatics, medical diagnostics, industrial damage detection, image processing, video surveillances, and novel topic detection in text mining. Here we will be keeping some of the very basic examples, like one of the very popular example of anomaly detection is intrusion detection. So here actually we are monitoring the events within the network or within the computer system, and whenever we are getting anything unusual, we try to identify that event with respect to some of the existing normal events. So that is basically occurrence of an anomaly. So anomaly detection is one of the very important task, very useful task to maintain the cyber security. Okay, but you can understand that there can be certain overheads which are there. So we need to overcome all those overheads in terms of preparing a very strong model, so that it can not only ensure the effective uh, classification in terms of anonymous and non-anonymous results, but also this whole processing should be a lightweight process. The another example of the fraud detection example. So fraud detection example means we are trying to understand the customers, maybe a genuine customer or maybe a malicious user, on the basis of their buying pattern. So this is something useful if we are doing it in a real-time fashion. So real-time fashion means we need to be very quick in terms of giving the decision making, and we have to work upon in a very faster environment with limited processing power. And the another challenging thing is, here the class of misclassification, the cost of misclassification is very high, so that we have to maintain. So there are various types of frauds which we can handle here, like credit card fraud detection, insurance claim fraud detection, mobile cell phone fraud detection, and insider tradings. Similarly, anomaly detection is useful to monitor the healthcare domain. So any anomalous patient record in terms of disease outbreak, in terms of abnormal vital parameters, can be detected on time for further preventive measures. So here again, we cannot bear the misclassification cost. So because these domains are very much critical, so and sensitive, so we cannot bear the misclassification cost. And here, most of the time you will feel that you are having the availability of the normal patient's data only. So detecting rare situations may not be very common. And the another thing is data formats are also not in a universal format. So we will be dealing with variety of data formats, and for any collective decisions we need to fuse them, and we need to extract the meaningful information from that. One of the another application is industrial damage detection application. So here you can understand, like most of the examples, for example, like aviation system. So aviation system, we are using the uh, various advanced uh, operational strategies, for example, like autopiloting mode, and for example, like controlling of this aviation through some data center. So here it is very important that we should able to understand any kinds of faults, failures, or abnormal situations correctly on time. So this can not only help us to maintain the actual working environment, but if suppose there are any kind of criticality, for example, like if there is a structural damage, if there are some kind of abnormal behavior of the particular aircraft or the particular machine, so that has to be detected on time for precautionary measures. So here we can say that the data is very vast in terms of size, and sometimes the data are unlabeled, data are noisy, and we are also dealing with the temporal behavior here. So generating information or availing the decision making capabilities through this spatiotemporal data is something which is a challenging task. Uh, then you can also see that most of these real-time applications, they are dealing with the image data. So if we are having image processing related task, so the purpose of these automated applications are to minimize the human intervention. So for example, like we are using video surveillance systems, and we want to minimize the human presence, or we are using satellite images for various kinds of analysis, and since the image capturing rate is too high, so all the time it is not possible to keep human in the loop. And even in the medical domain, most of the medical imaging technologies, they want to automate the processes because of limited availability of the experts, and also to support the experts capabilities in terms of gaining correct information from that particular image. So basically all these types of domains, image processing domains, it is very important that we should able to process the images very carefully for detecting any kind of anomalous region within that image, or for detecting any kinds of outliers. So basically, these are the key challenges, like detecting collective anomalies when the data set is very, very large. So moving with this, I will be taking here some of the aspects of anomaly detection problems. So first thing is like what is the nature of the input data? Then what kind of supervision we are trying to follow? Then the types of anomaly, then the output of anomaly detection, and finally the evaluation of anomaly detection techniques. So we all understand that if we are dealing with the data instances, so data instances can be representing an object, record, point, vector, pattern, events, cases, samples, observations, or entities. So we can also understand that data instances can be described using set of attributes. So if we are taking the help of only one attribute, so you can say that it is a univariate representation of the data. Or if we are representing the data instances with the help of multiple attributes, so it can be multivariate representation of data. Okay. And once we talk about the multivariant variate data instances, so it is very likely that all the attributes are not having uh, same type of representation. So they may have different types of data formats. So, and on the other hand, we can also see like we will be having various combinations of the nature of the attributes. For example, like one parameter can be represented through the binary number. The another parameter can be represented by some kind of continuous values. The another parameter can have the categorical representation. So sometimes what we say that if it is a multivariate analysis, it is having all these possible set of combinations available. Uh, Input data is also referred in terms of its complexity, and that is the relationship among the data instances. So sometimes the data instances are sequential, and they are sequential because they are having the temporal characteristics. Sometimes the data instances are spatial, or sometimes it is spatio-temporal kind of data, or sometimes it may be the graph data. So these are the various kinds of data which are available in any application domain. So we need to accommodate all these types of data samples if we are trying to calculate the anomalies. So anomalies can be very much subjective. So for example, like sometimes the anomalies are nothing but they are the novelties. Okay. So, so how to understand that this particular anomaly is a kind of novelty? Because if we are considering it as a novelty, then it is our responsibility uh, to adopt that situation. And sometimes the anomalies are because of uncertainty over the environment. So that we have to handle. And sometimes the anomalies are as a result of certain form of disagreements. So we have to accommodate all those situations for while handling the anomaly detection task. So here we are focusing on three types of anomalies. One is the point anomaly, second is the contextual anomaly, and third one is the collective anomalies. So point anomaly is a simplest form of the anomaly. Here we can assume that individual data item, maybe suppose this one is anonymous with respect to the normal data instances. So here the normal data instances are basically N1 and N2. And so this O1 is anomalous because it is far away from these normal instances and it is not uh, lying down in these normal distributions. So that may be a case. That is the point anomaly case. Contextual anomaly means the individual data instance is anomalous within a context. So, okay. So here the context is very, very important. So for example, like if we are taking the temperature and time in X and Y axis, and we are trying to see the behavior through the help of certain graphs. So you can see like if it is the month of December, which is usually a winter season, and if we are having this drop in the uh, temperature, so that can be normal. It is not anomaly. But sudden drop in the temperature during the summer season, which is June here, so that can be an anomaly. So here the values are same, like T1 and T2, both are having the same value, but T1 is not at all anomalous, but and T2 is anomalous because of the context. And the context is here the weather condition. So monthly weather condition. So here the weather condition is summer, and here the weather context is winter. So that is basically a kind of anomaly. So if we are considering the contextual anomaly, so we will be handling two types of attributes. One is the contextual attributes. So for example, in a spatial data sets, the longitude and latitude of a location are the contextual attributes. Okay, and even in the time series data, the time is contextual attribute which determines the position of an instance on the entire sequence. So here, like if we say the various months of the whole year, so we can say that summers, winters, these can be the different contexts. So this uh, time is something which is a contextual attribute. Sometimes the contextual anomaly can also be calculated with the help of behavioral attributes. So for example, in a spatial data set describing the average rainfall of the entire world, the amount of rainfall at any particular location can be a behavioral attribute. So sometimes at any local location there are certain patterns or characteristics existing, and then that can be considered as a behavioral attribute for the observation uh, of availability of any particular anomaly. So these contextual anomalies are also known as conditional anomalies. The third category of the anomaly is collective anomaly. So collective anomaly means a collection of related data instances uh, are abnormal, and here we requires a relationship among data instances. For example, like sequential data, so they are occurring in a repeated pattern, spatial data or graph data. So here you can say that some normal activities are going on and suddenly we experienced some kind of anomaly. Okay. So it is a collective anomaly because this particular reason, it is not following the relationship in terms of the sequential data. So it should be noted that while point anomalies can occur in any data set, collective anomalies can occur only in the data sets in which data instances are related. So actually we are observing these kind of pattern here, but it is not occurring, so it can be a collective anomaly. So a point anomaly or a collective anomaly can also be a contextual anomaly if analyzed with respect to a context. So this is the anomalous sequence which we have identified. So we need to understand the type of anomaly. So we have seen that there could be three types of anomalies possible. And then we can also understand the various data labels uh, through some kind of approaches. So first is the supervised anomaly detection approach. So supervised anomaly detection approach means we are already aware about the class level of the normal data and the anomaly data. So it can be a rare class mining. So it suggests that actually we are having some preparation about the occurrence of that particular event that can be an anomalous event. The another approach could be the semi-supervised anomaly detection. So here the class levels are available only for the normal data, but we are having very limited or maybe not maybe non-availability of the anonymous data. So third category is unsupervised anomaly detection. So here we are not assuming any presence of the class level, but we are taking a relative concept that anything which is not normal can be considered as an anomaly. So it should have some different behavior as compared to the normal pattern. So that can be unsupervised anomaly detection technique. So what I can conclude here, like in the supervised anomaly detection, anomalous instances are far as compared to the normal instances. Okay, and in semi-supervised anomaly detection, it is very difficult to get the idea about the anomaly kind of class levels. So either we have very limited information or we are only dealing with the levels which are available for the normal data. So this becomes little challenging. The next important point which we can discuss here, like what should be the output of the anomaly detection. So sometimes we just assign the labels. So label may be normal or anomaly, and it is the most common approach if we are following the classification based approaches. But sometimes we are not actually assigning the labels, but we are assigning the scores. So normally score, we can say that we whatever observations we gather, we rank the observations, and according to some threshold parameter, we can take certain observations, maybe serious anomaly score, or some observation may be weak anomaly score, or that can be non-anomalous or normal occurrence. So these are the various methods of representing the output of the anomaly detection technique. Now I am coming to the various types of anomaly detection techniques by using a taxonomy. So you can see that we are having the first very common anomaly detection task, that is the point anomaly detection task. So this point anomaly detection task is divided into 4 major classes, and there are some other approaches also. So first technique is basically the classification based techniques. So classification based techniques, it is uh, uh, fully supervised techniques, we can say. So here we are using certain existing approaches like rule based, neural network based, SVM based, and nearest neighbor based. We can also detect the point anomaly with the help of clustering approaches, and statistical parameters can also be utilized. Other than this, there are some approaches, for example, like information theory based approaches, spectral decomposition based approaches, or visualization based approaches for detection of point anomaly. There are some methods exist where we try to understand the contextual anomaly or collective anomaly in the light of where we are having the normal data processing, or we are processing the data when it is at rest, or we are processing the data in online fashion. So online detection techniques are also existing. And in most of these recent applications, since we are dealing with the data which is coming from the various resources, so we are going to handle the distributed processing for the anomaly detection techniques. So these all are basically the classification of the anomaly detection techniques. So first, we are taking the classification based techniques. So classification based techniques means we are trying to build up a classification model for normal events and rare events or anonymous events based on the training data. And we are trying to generate some kind of class labels. So whenever we are experiencing any new data samples, these data samples can be labeled in terms of normal or in terms of abnormal way. So that is basically the first case. So here we have two categories. One is the semi-supervised techniques. So semi-supervised techniques means we are going to one is the supervised learning technique. So we need the knowledge of both normal and abnormal classes. And second is the semi-supervised classification techniques, where we are limited to the knowledge of the normal class only. So these are the two techniques for deriving the anomaly detection methods. So here again, like a typical methods, we will be having a training phase. So an anomaly detection system first creates a profile of the normal system, network, or a program activity. Then the testing phase will be used to detect any kind of deviation from the normal profile. So these test instances is classified as normal or anomalous using the classifier. So here, as we said that it is already quoted that sometimes we are not having the samples available from the anomalous class or rare class. So here what we can do on that type of cases, we can take the help of one class classification based anomaly detection technique. So that we are taking in detail in our later part of the tutorial. So here we assume that uh, uh, like one class classification is a type of classification techniques where we assume that all the training instances have only one class levels, and any test instance that does not fall within the learned boundary, which we can see here with the help of this diagram, so that is declared as a rare class or anomaly. So that is basically one class classification. In a multi-class classification based anomaly detection techniques, here we can understand that there could be multiple possibility of normal classes, or there could be multiple normal classes, and if any test instance is not coming within any of these normal classes, so that can be identified as anomaly. So here you can say that we have taken three normal classes, but still there are few data instances it is not falling any of these category, can be referred as a anomaly. So this is basically the multi-class anomaly detection technique. So there can be various methods of handling this supervised classification techniques for anomaly detection. So first thing is we can handle it at the data preparation level. So for example, we can handle the cases of uh, 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 oversampling, undersampling, and we can also manipulate the data records so that we can get the balanced samples by using some artificial generation of the data sample techniques. Then the another possible methods of anomaly detection is to use rule-based systems. So as we said that we will be preparing a normal profile and we will be observing the deviation from the normal profile. So this preparation of the normal profile can be with the help of through some threshold value. So if we are generating certain rules with the help of these threshold values, so that can become a rule-based system. And we are just checking any of the test sample if it is not falling or if it is falling at this particular section of this rule based system, so that can be accordingly labeled as normal or abnormal or anomalous. Okay, then we are also having the model-based techniques for anomaly detection. So model-based techniques means we can go for the support vector machine classifiers, we can go for the Bayesian techniques, or we can go for the neural network-based approaches to identify any of the abnormal pattern. And we sometimes it is also very common that we can use the ensemble-based algorithms for anomaly detection techniques. So let us take one example how support vector machine is helping us to identify whether the anomaly is existing or not. So we can say that with the help of support vector machine, actually we are trying to classify the data into two planes, for example, like positive samples or negative samples. And we understand that normal data records belong to the high density data regions, and anomalies are always distinct. Anomalies are always at the low density data regions. So basically, here the classification approach uh, will work to with the help of an unsupervised approach, so that we can learn what are the parts of the data which are actually having the high density representations and what data are actually having the low density data representation. So if we are having these two classification in terms of high data representation and low data region representation, we can use support vector machine to classify the data density levels. Okay, so here a typical SVM methods can be used to classify the normal network behavior, or there can be an intrusion occurrence. So here one class classifications are also used in a similar fashion. So here we separate the entire set of training data from the origin, in such a way so that it can able to identify a small region that may be spherical or some kind of reasons, and we assume that uh, those data which are belonging to the close affinity or within that region may be a normal data, and if any data sample which is coming uh, uh, away from that normal region can be an anomalous data. So basically here we are trying to just see the variance of data distribution, and we are also checking that means it can be one of the method to detect the outliers, where we can say that how many data samples are not falling in the normal region. So so that is basically one of the technique which we will be explaining in detail in our subsequent sections. So other than this, we are having some kind of semi-supervised classification techniques. So semi-supervised classification techniques means since we are having only one class data available, so that is very likely that we are having the normal behavior representation only. So we would learn sufficiently with the help of the normal behavior data. And if there are any deviation from the normal behavior, that can be considered as anomaly, even if it is a rare normal condition, but it can be quoted as anomaly here. So to support this approach, again we are having various techniques, SVM based or neural network based techniques for the purpose. So I'm now concluding the classification based techniques. So we have this supervised classification techniques where the models can be easily understood, and where it can be a highly accurate model to know the type of anomaly which is obvious. In semi-supervised classification techniques, model can be easily understood, and normal behavior can be easily learned, and any of the expected behavior can be identified with respect to the normal behavior. So these are some positive points. If we try to see the drawbacks, so drawbacks are in supervised learning techniques, we need a very concrete information about the normal classes as well as the abnormal classes, and uh, means if there is no prior class level is available, then there may be difficulty to understand any kind of emerging anomaly or new anomaly or unknown anomaly. In semi-supervised classification techniques, uh, we need data from the one class, that is the normal class, but it is having very possible high false alarm rate, because all the previously unseen data records may be recognized as anomaly, and which may not be true for most of the cases. So so now let us see the another types of anomaly detection methods. For example, like nearest neighbor based anomaly detection method. So here we are working with the assumption that normal points have close neighbors while anomalies are located far from the other points. So this is the core assumption if we are working with the nearest neighbor technique. So here what we need to do, we will be following two steps. First is computing the neighborhood of each data record, and then second step is analyzing the neighborhood to determine whether the data record is anomaly or normal. So here we will be having two categories. One is the distance-based methods. So distance-based methods means anomalies are the data points which are most distant from the other data points. And second is the density-based methods. So anomalies are the data points in low density regions. So there could be any of these possibilities. So here one of the popular approach is local outlier factor approach. So you can see here we can see the data distribution. It is very dense, and it is not very dense, but most of the data points are together. So you see this P3. P3 is one data point. So distance from P3 to the nearest neighbor is, you can say that it is very closely located. And here the distance from P2 to the nearest neighbor is this one. So what we can say that in the nearest neighborhood approach, P2 is not considered as an outlier, while in the local outlier factor approach, LOF approach, it finds both P1, P2 as an outlier. So nearest neighbor approach may consider P3 as an outlier, but LOF approach does not. So basically, there are various ways to consider the concept of the outlier. Sometimes it is density based and sometimes it is distance based. So both are very important and both can work depending upon the various context. So if we say the advantage, so advantage is basically it can be used in unsupervised or semi-supervised settings. So because we are not having most likely in unsupervised fashion, we will not be having any assumption about the data distribution. So if we see the drawbacks, so drawbacks are first thing is like if the normal data points are not having sufficient number of neighbors, so even they are normal, but it may identified as an anomaly, and it is computationally expensive. Like all the time you need to calculate the nearest neighbor and the distance from the particular cluster. And the another difficulty is like it may be a little difficult if we are dealing with the high dimensional spaces. So if it is a high dimensional spaces and if the data is having the sparse characteristics, so so distance between any two records may become quite similar. So each data record may be considered as a potential outlier. So for sparse data, the close affinity of the data points may not be available. So that can give some kind of ambiguous results. Okay, so third kind of anomaly detection technique under point anomaly is clustering based. So clustering based, we have understood that it is a kind of unsupervised approach, but it can also support some of the semi-supervised scenarios. So unsupervised approach means we will be completely unaware about the occurrence of the data as an anomaly, but uh, somehow we may able to identify certain kind of features like that. So here in semi-supervised approach means maybe we are not having any idea about the new data instance, uh, and since it is not following any of the existing clusters or categories, it can be identified as anomalies. Okay, so here we can say that these techniques are very useful when we are having lack of domain knowledge and when we are having the semi-supervised kind of situation. uh, there are certain difficulties. For example, like sometimes the data records, if it is not fitting to any cluster, but it may be normal, can comes as an anomaly. And sometimes we can find out that there may be occurrence of multiple clusters, or sometimes the low density clusters or local anomalies can also be possible. So advantage is we are very much free from the burden of taking the supervised data and having all the class level known, and so that is the advantage here. And since in these kind of techniques, it is also identified that they are very much handy if we are working in with the real time analytics part, or if we are working in a online mode or incremental mode by using some kind of data streamings. And the drawback is basically the computational expensive. And the another drawback is if the cluster formation is not well, then it can fail. The another drawback may be if the data is sparse, then again it will not give any conclusive results or meaningful cluster. So these are some of the drawbacks of clustering based techniques. Okay, now there are some other techniques also for point anomaly detection. So let us see one, that is the statistical based techniques for point anomaly detection. So when we talk about the statistical parameters, so nature of the data is very important here. So we see that data can be univariate. So univariate means only one variable. For example, it can be referred to any expression, equation, function, or polynomial of one variable. So that is one possible case. And here the parameters are modeled as the independent variable, thus defining an acceptable range of values for every variable. So second is the multivariate models. So multivariate models means this model is basically considering the correlation between more than one variables. So that is multivariate model. So the third category of statistical based methods can be with the help of time series models. So here, this model uses the time related metrics, for example, like interval timer or event counters or some kind of period of time representation. And here the ordering is also important, and the inter-arrival times of the observations and their values are important. So here, any observed behavior will be labeled as abnormal if it deviates significantly from the normal pattern, which is established during the with the help of the time-related metrics. And we can also see the statistical based anomaly detection techniques in two categories. One is the parametric techniques, and the second is the non-parametric techniques. So parametric techniques, it assumes that the normal data is generated from an underlying parametric distribution. So we need to learn the parameters from the normal samples. Okay. So we have to understand the overall data distribution for this purpose. And non-parametric techniques means we do not assume any knowledge about the parameters, and without this we need to learn from the distribution. So basically these are the two another categories. So if we talk about the working methodology while taking the statistical methods for anomaly detection is, so we need to again capture the information with respect to time and behavior over a period of time as a normal profile. And then we need to compare this currently observed behavior with the normal profile or previously trained statistical profile to identify the anomaly during the process. So advantages are since it is most of the time containing the information which is related to the sequential pattern, so we can get more and more ability to learn from the existing data, and accordingly we may have firm decision about identification of any anomalies. And disadvantages means if there are some serious attackers, so they try to understand or they try to guess the various statistical parameters in advance, and they try to design their attack, that can be any anomalous or rare activity, in such a way so that it will be very difficult to identify the difference. And if we are working with the help of certain threshold values, so these threshold values, if they are not correct, they will be leading for false positive and false negatives. And we can say that sometimes even if we are having all kind of parametric and non-parametric experience of learning, but it may not be sufficient enough to model the overall statistical nature of the particular data. So that is again a difficult task. There can be some other techniques which can be useful for the point anomaly detection methods. So for example, uh, entropy based approaches. So we suppose if we are having certain experience that any information with respect to a particular context is useful, and the term can be represented with the help of the entropy. So if we are observing any deviation in these entropy values and the relative entropy value, so that can also be identified as a rare condition. And that is the thing. The another thing is we can also detect the smallest data subset whose removal leads to the maximum reduction in the complexity, and that can help us to understand the data pattern and labeling in terms of normal or anomalous data. Okay, so here basically we need more information about all those theoretic measures, so that we can understand the context well, correctly, and we should not miss the uh, information while dealing with such type of techniques. And one more technique is the spectral technique. So a spectral technique means identifying some of the key parameters based on the eigen decomposition of the data, for example, like principal component analysis. So here we try to identify some of the useful attributes or a combination of attributes, and we try to reduce some non-useful attributes. So because we understand that these non-useful attributes may not be contributing much, so with the help of this we may able to give more focus towards the capturing of the normal data. So because most of the time this outliers they are exist in terms of the certain kind of variations. So if we are having some reduced space, so we can easily see the principal components, they are prominently representing certain values, and it can give a huge difference in terms of observation of a normal data samples as well as the anomalies. Lastly, we will be observing the point anomalies with the help of some basic visualization based methods. So visualization based methods means an anomaly can be seen visually. So here it is important that we can keep human in the loop, and disadvantages can be like it may be handy if we dealing with the low dimensional data, but it can be tricky if we are having the high dimensional data items. So you can see that it will be helpful if we are working with the exploratory data analysis. So exploratory data analysis can help us to understand the nature of the data. So any abnormal thing we can represent with the help of some of the visual representations. For example, like we can use the spikes, we can observe the spikes in the visualization, we can have different color codes to represent the different kind of uh, instances, which may be the anonymous instances, so that can be very much seen. Okay, so we will be having some other approaches also for the contextual anomaly detection. So as we have already discussed, contextual anomaly detection means we need to detect the anomaly with respect to certain context. So first thing is we need to identify the context and we need to define the context. So as we have seen in the previous example, like we identified the context as like a weather condition, maybe summer or winter, and the temperature value which is too high, it is normal for the summer season, but if it is too high during the winter season, so it becomes abnormal. So we have to see whether the particular data instance is abnormal with respect to context using some set of attributes. So here we have seen that we will be having two types of attributes. One is the contextual attributes. So here we are basically identifying the context around the data instances. And the second type of attribute is the behavioral attribute. So here we are determining the data instances that is anomalous with respect to the particular context. Okay. So here, so I think these are having the advantages like uh, it can detect anomalies that are hard, that are very much hard to detect when analyzed in the global perspective. And the challenges thing is like we need to identify the contextual attributes. So it's again an art or again a challenge to identify the good contextual attributes. And we have to also correlate the observations with respect to certain context. So that is something which is important. Uh, so we have various kind of contextual attributes here. For example, if we are talking about the spatial context, so it is latitude and longitude. For graph context, it is edge and weights. For sequential context, it is position and time. And we can also have the profile context, for example, like various kind of graphics. So there are some methods to deal with the contextual anomaly detection techniques. So first method is we basically uh, simplify this contextual anomaly detection technique to the point outlier detection technique. So here what we do, we segment the data using contextual attributes, and then we apply the traditional point outlier within each context using the behavioral attribute. So basically it is a simplification part. And then we also utilize the structures in the data, and we build the model from the data using contextual attributes, for example like time series models. So this is one example of conditional anomaly detection techniques. So conditional anomaly detection technique means we are basically representing the data points, which is represented as x comma y, where x is representing the environmental or contextual attributes and y is representing the behavioral attributes. And we will be having the mixture of Gaussian models. So NU, it is here U is the learned from the contextual data, and mixture of NV Gaussian model where V is the learn from the behavioral data. So we are trying to map between these two Gaussian models, one which is learned from the contextual data and second which is learned from the behavioral data, in such a way so that the probability of the behavioral part can be generated by the component of Vj when the contextual part is generated by the component of Ui. So basically we are trying to generate the components from both of these Gaussian models. And with the help of all this, we will be using this formula to calculate the outlier score of the data instances. So that is about the collective anomaly detection. So basically collective anomaly detections are useful in some sense. For example, like if we are dealing with the sequential data, so sequential anomaly detection can be one of the methods of collective anomaly detection, where we assume that overall sequence could be normal or anomalous. Or similarly, we can have the spatial anomaly detection, where we need to detect the anomalous subregion with respect to some kind of spatial data set. And similarly, we will be also use this through the graph anomaly detection, where we can identify some of the subgraphs within the graph system. So that is basically the collective anomaly detection. So okay, let us see more details about the sequential anomaly detection. So, anomalous sequence may within a sequence may be very common. So it can be seen in climate data, for example. So basically, data can be represented in terms of set of symbolic sequences. So we have to learn the data sequences with respect to some reference point, you can say. So how we will be doing it? since it is a sequential data analysis, so there is a one method which we call sequential time delay embedding style. So here we assume that data is coming from the normal sequences, and we identify some sub part of this sequence, maybe subsequence, by the sliding window concept, and then we try to learn the data for each of these sliding windows. So that will be our training part, and we maintain the count for all the subsequence within the training data. And then for the testing, we extract the same size of window uh, 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 and the same size of subsequence from the testing sequence, and we try to learn the empirical probability of each test subsequence from the above count. If the probability of the subsequence is below the threshold, we assume that the subsequence may be deviating from the normal expectation, and that count of these mismatch in terms of the probability with respect to certain threshold may be reported as an anomaly score. So this can be used for any kind of log based anomaly detection or intrusion detection arrangement. Uh, Now we will be having two more types of anomaly detection. So one is the online anomaly detection. So you can understand online anomaly detection is a technique where we are considering the continuous arrival of the data, and these are some of the applications like video analysis, network traffic management, aircraft aviation system safety management, and credit card fraudulent transaction details. So that kind of activities can be handled here because we are actually performing the real-time anomaly detection. So here we can say that it is a little challenging because the normal behavior is changing throughout the time. So we need to update the normal behavior profile dynamically. So every time, maybe like we need to update our reference window, which is containing the information of the normal profile. uh, uh, so uh, mm, so if something some occurrence of the behavior, if it can be compared with the normal behavior or the reference window, so if they are having similarity, so they can be uh, safe, or they can be having very low anomaly score. So basically this anomaly detection algorithm has to be updated time to time, or in every time slot, in terms of its profile updation part, and in terms of taking new test sample in the uh, for the comparison purpose. So online anomaly detection techniques are, you can say that basically it is a continuous activity. So every time we are getting the samples of data, so we need to means we not only need to maintain the historical information about the data pattern, maybe in terms of comparing it uh, for the observation of normal or abnormal behavior, but also we need to accommodate some new data samples. So that is something which is very tricky. So for that purpose, we use the sliding window kind of concepts. So here we can see that we have represented a anomaly detection application design which is using the Kafka cluster, and here through Kafka cluster we are trying to give the data as an input, and these data is actually going to represent the whole pool, and the whole pool is trying to calculate the real-time anomaly with the help of the Cassandra cluster, and this Cassandra cluster is actually having the historical data for the reference for the comparison purpose. So it can work with the streaming data for this purpose. So there is a drawback of online anomaly detection algorithm. So sometimes what will happen? like whenever we are having some surprising data points, and if the surprising data point starts to create a new cluster, this method will not be able to identify this as an outlier, and that becomes a little difficult. Okay, so lastly, we will be having the distributed anomaly detection techniques. So distributed anomaly detection techniques means we can understand the scenarios, in most of the applications, we are gathering the data which is coming from the multiple sources. So that can be network intrusion data, aviation safety data. So there are certain features of these data elements, like they are streaming in nature, they are coming from the different resources. So that is something very difficult to manage. So here what we do, here basically we try to run the distributed algorithms for the identification or of the anomalies yeah. So basically you can see this. So basically here, suppose if we are dealing with the Spark systems, so Spark systems means we will be using multiple RDDs simultaneously to learn uh, anomaly in terms of training and testing it in a parallel fashion, and this way we are trying to predict the classes. So this can be also helpful if we are following proper feature extraction and sample size reduction technique. So maybe our overhead can get minimized here in terms of distributed anomaly detection. So Spark environment is using the uh, like a cluster manager to deal with the worker nodes, and these worker nodes, they are actually running the anomaly detection algorithms parallelly for the local set of data, and finally it can be combined together to develop the complete set of model, which is basically the distributed anomaly detection model, which is basically the distributed anomaly detection model. So, coming to the important points of distributed anomaly detection techniques, that is basically the challenges which are underlying. So, most of the important challenges are like we are having very uh, uh, much high volume data. So high volume data is again having some difficulties in terms of handling its uncertainty, its performance expectation, and its scalability part. And similarly, if we are considering the velocity part of the distributed environment, so sometimes the data instances are asynchronous, sometimes they are having dynamic relationships, they are heterogeneous in nature, they are suffering from the concept drift. So basically these are the things. Other important parameters are like most of the time these distributed anomaly detection techniques are dealing with the high dimensional environment. So high dimensional environment means how to collect the relevant features, that is important, how to measure the distance, that is important, then how to identify the subspace selection, and the hubness parameters are actually something which is very important while dealing with the distributed anomaly detection techniques. Okay, so suppose if we have gone through all these anomaly detection techniques, so one more thing which we can try to understand, like how we will be calculate the performance of the anomaly detection. So you can understand that accuracy is not a sufficient measure of evaluation, because even if you are calculating the 99.9% of uh, means normal data and 1% of intruders, then there may be possibility that some of the intruders you have counted over the normal data. So that is something, means explainability is very important here. So accuracy is not very sufficient metrics. So here we can rely upon the f values. So f values are basically we can have the combination of recall and precision to get more confidence about the detection of the anomalous class and normal class. Other than this, we can calculate the detection rate with the help of recall. So here we can calculate the ratio between the number of correctly detected anomalies and the total number of anomalies. We can also take the help of false alarm rate. So it is the ratio between the number of data records from normal classes that are misclassified as anomalies and the total number of data records from normal classes. We can also take the help of ROC curve. So it is a trade-off between detection rate and false alarm rate. So basically, these are some of the measures which can be taken collectively to identify the performance of the anomaly detection approaches. If we conclude the whole state of the art of the anomaly detection, so we can say that like anomaly detection is something which is a very tricky task. So sometimes the boundary between normal and abnormal behavior is not very precise. So classifying purely in terms of or clearly in terms of normal and abnormal behavior may not be possible in most of the context. Okay. So the another challenge is like anomalies are because of the result of some kind of malicious actions. So whenever somebody is deliberately targeting certain malicious actions, so so it is a strategy that these malicious actions may be planted like a normal activity. So sometimes it will be very difficult to distinguish between the anomaly and the normal activity. So these are the two important difference. And what you say that there is one more criteria like this normal behavior is also something which is keeps evolving, and the current notion of normal behavior may not be sufficient enough to represent the normalcy in future. So that can also be seen as a anomaly in future. Okay. And the another challenge is like the definition for anomaly is very different in different applications. For example, like a small variation of health vital parameter may be very crucial in health monitoring system, but a small variation in stock market may not be very crucial. So that is something challenging. So because of this, it is difficult to develop a universal solution for anomaly detection, because most of the time it becomes the domain specific or context dependent. The another parameter problem is like the availability of labeled data for training and validation for anomaly detection task is not sufficient. So that is again affecting the performance of various classifiers. And then the last part is we can say that like anomalies and noise, these are the two different things. Okay, so we need to understand these anomalies and noise differences very well, so that sufficient measures can be taken for handling these two issues. So with this, I'm coming to the end of the part one, and here we have covered all the learning strategies and the state of the methods of the anomaly detection techniques. So I hope this will give enough idea to understand the various methods of target class learning. Thank you.